Okay, so today we're talking about timber frame buildings, their history, care and repair. And of course, the first thing is to recognise what you are dealing with. And quite often, the frame is well buried within the structure. On the left-hand side of the screen there, you can see that as you pass this farmhouse in one direction, looks like an 18th century farmhouse, and it's only when you travel in the other direction that you see that it's a medieval jetted timber frame building. All they've done is upgrade it on the side that faces the road and the village with brickwork, basically to give it its best face to the public. And the timber frame you can see down the side. Sometimes it's only the timber frame visible at the back. And on the right-hand side of the screen, again, you can see a rather fine late 17th century facade in beautiful brickwork. And again, only when you look carefully on the end elevation, you see the timber frame. So these buildings get changed in time. And sometimes it's incredibly difficult to find the frame on the evidence. So here we've got a coaching inn, which is showing a late 18th, early 19th century facade to the road. And it's only when you go down the side that you start to begin to see that it's a medieval coaching inn. And originally it had open sort of galleries here to give access to the various rooms of the coaching inn. So it was sort of a medieval motel. And here in Bergen, you can see sort of an example that's unwrapped of its cladding to give you an idea of what it may well have been like. And again, here we've got what, to all intents and purposes, were unlisted 19th century farm cottages. And it's only when someone bought the pair of cottages and started to unravel them and modernise that we discovered a medieval building inside. The front elevation had been risen in height. The end elevation here had been tile hung, so it covered the frame. And the chimney here had been built over the top of a medieval window, which you can still see retaining its two of its vertical bars, diamond set sort of mullions. So it's a case of discovering what you are dealing with. The other thing to remember is that buildings evolved through time, and that's also true of timber framing. And so here on the left, you can see what started its life as a crook cottage of 2 bays with its eaves line down here at sort of door head level. It then gets heightened by a frame height here and the roof repitched. And then later, a gable is added facing the main facade, and a cat slide single-storey structure at the end, and then eventually the whole thing is turned into a 2-storey building. So we've got at least 5 phases of development in that one building, and anybody sort of doing repairs or modernising, cut the wrong timber at your own risk. Everything sort of is relying on everything else there, and it's all fairly precarious. The centre photograph here, you can see timber frame building, but again, it's changed through time. Originally, it had an open hall in the centre section here, with hearth open fully to the roof, with 2 wind eyes, these little gablets at either end of the ridge, allowing a sort of through movement of air to clear the smoke. Quite often, it's only when you get inside buildings up into the roof space that we see evidence for either a smoke bay, as in this case, with the smoke-blackened timbers and wattle, and then a later brick chimney built through it. On the bottom photograph here, you can see that this has been upgraded as an 18th century farmhouse, and in fact it was listed as such. And it was only when renders started to peel off this gable end that it became apparent that we're dealing here with a timber frame building with very fine close studding on the end of it here. Dated it to 1592. The windows were still intact underneath the render. They had been blocked at the time of the window tax. And so the whole thing had been sort of upgraded in the 18th century with sash windows, etc. But anybody passing, if you look at that main central stack, it rather does suggest that one's dealing with something earlier than an 18th century building. So, what are we dealing with? What sort of date is the building? 50 years ago, you sort of looked at the joints, you looked at the general structure, you know, put a finger in the air and suggested, well, it could be 13th century or whatever. But about 50 years ago in America, they started to develop a system of looking at the age of timber by looking at the tree rings. This is called dendrochronology. And they started sampling some of their giant redwood trees and found that some of them were well over 1,000 years old. And the rings, the tree rings, illustrate the growth of the timber over time. And depending whether it was a wet season or a dry season, you got a different width of ring. And the pattern of the seasons over 70 to 100 years, you can chart by very carefully measuring the growth of these rings and plot it on a master chart, a master chronology. And then any sampling you do, we just take a very small sample, a core about the size of a pencil out of the timber. And basically one aims to try and get from sapwood right the way through to heartwood. You can then carefully measure the width of these rings, and you can compare it with a master chronology that we built up over the last 50 years for the south of England. And quite often, if you've still got sort of the last bits of sapwood or bark, you can tell exactly when the tree was felled. And this is very useful when you're trying to tie building to documentary evidence. So in the case of the building above here, this is the, what was the, was listed as an 18th century stable block at Warewell Priory in the Test Valley in here in Hampshire. It was only when you got up above the false ceiling in the loose boxes one saw this sort of forest of slender timbers with joints that were extremely archaic. So we're obviously dealing here with a medieval building, and there's the sort of drawing of it. And the dendrodating came out that the trees was felled in 1249. And this enabled us to go back to the documentation for the medieval priory, and we found the abbess Euphemia built a new infirmary, a new guest block in 1250. The N2 bays, the joints looked a little bit different, and the dendrodates from that came up 20 years later for the felling date. And again, going back to the documentation, we found that the building was extended at that point. So what dendrodating does, where you've got buildings with good documentation, it allows you basically to find that needle in the haystack. It's hopeless sort of just blindly going into the pipe rolls and building accounts. You really do need to be able to focus on a date to be able to find the details. Um, Sometimes it's only when building works occur that one begins to discover the true date of a building. So here in Romsey, just behind the Abbey, we have a building which again was listed as an 18th century house. But when works were done on the roof, it was discovered again there was lots of slender timbers, and also later a raised crook roof within, which was helping this earlier roof to stop sagging around, etc. And again, the date came out as 1220, and in fact it's the original refectory to the Abbey, which was not known about until the late 1970s. Well, just a word of caution about using dendrodating. Quite often buildings have got reused timbers within them. And here's a very good example. This is the Chesapeake Mill at Wickham near Portsmouth in Hampshire. And here we know that these huge timbers within the floor structure don't belong, they're reused. There's lots of sort of open sockets. And again, looking at the documentation, we find that the very enterprising miller bought from the Portsmouth dockyard the great deck beams from a warship which was being dismantled. It was the captured warship, American warship, the Chesapeake. And so this is one of the rare occasions when you actually have got ships' timbers within buildings. I only know of 2 examples in the south of England, and this is one of the documented ones. Many clients talk about ships' timbers and they look at sort of the curved braces. Well, yes, there is some sort of documentary reference to these curved timbers being known as ships' timbers, basically because they're used for the bracing within ships, just as the same as the bracing within houses. So you're using the same sort of basic timber source. More often than not, what you find in buildings is timbers like this post, which has got open mortise holes with nothing in them, and the shape of the holes and all the suggestions is that this in fact was a principal beam out of a ceiling, which has been reused as a post at a later date. So if you're doing dendrodating, you have to be very, very cautious that you're dating a piece of primary timber and not reused in a building. And just to sort of emphasize this, here we've got what's apparently a very simple barn of 7 bays. It's only when you get inside that you realize that you're dealing with something much more complex. At one end of the building, you've got beautiful square framing that all fits correctly, a very nice continuous butt purlin roof here. But what's interesting is in some of these panels, the middle panel of each of these bays, the upper panel, there's these holes, diamond-shaped holes in both the underside of the wall plate, and you can see broken out here from the mid-rail is similar matching holes. And this was for mullions for windows. So in fact, this building, the first 4 bays of it, start off their life as in fact a domestic building. And the truss number 4 here has got empty mortise holes showing that originally there was a full timber frame at this point. It was then extended at a later date by 3 bays, and interestingly, in these 3 bays, it's completely made of reused timber. So someone has dismantled another building on this large country estate and reused the timbers to make an extra 3 bays on this building and convert the whole lot into a barn, probably at the latter part of the 18th century. And the building that they scavenged the parts from had wattle and daub infill panels. You can see the evidence here. There's a wattle groove on one side of this timber, and on the other side you've got stave holes. So these were both in, this was in a horizontal position, probably a mid-rail, and there's all the evidence. So you have to look very, very closely at these buildings to really begin to understand them. The other point is that the joints and the shapes of the frames and the sort of building technology changes through time. And at the early period, we get very simple lap joints, as you can see here, that are pegged. But if you're just relying on the peg, it's a very weak joint with these half-lap joints. And so they were improved by putting a notch in them so that you're pulling on a little bit more timber here. So structurally, they work a little bit better. And eventually, the notch is put sort of inboard the joint. You don't actually see it. And there is a sort of a development through the 13th century of this sort of joint at the beginning of the 13th century. We then move into, by the 1250s, we're into sort of full mortise and tenon joints, which work much better mechanically. Likewise, things like roof structures change, with particularly the position of purlins. On some of the early roofs, you get a central purlin running down, picking up all the collars, and quite often with the crown post picking that up to stop racking of coupled rafter roof. Eventually, the purlins move to the side of the building, and very typically in the south of England, you get these clasped purlin roofs where the purlin is clasped between the collar and the principal rafter. And so there's a whole sort of development of roof structure. We also get a basic change in frames. Down in the south of England here, we have two types of main framing traditions, both the box frame and the crook frame. And I'll go more into that in a short while. Well, the early buildings, when you look at them, they're sort of a forest of slender timbers. And there's quite a lot of similarity between our great medieval barns of the late 12th and 13th centuries and those in Normandy in France. As one would expect, you know, there's close links in the medieval period between the two countries. Well, what's very interesting when you look at these early barns, they seem to be sort of set out to a particular sort of series of measurements, and when you sort of scribe circles, you can see how all the posts seem to fall in where circles sort of overlap to give you the position of the aisle posts, etc. So it would appear that in the medieval period there was a language of geometry for setting out these buildings, and also sort of standard measures. And sort of in old measure, it seems to be multiples of 4 feet working up through, and to sort of 16 foot is quite often a standard span or a standard sort of bay distance in these buildings. And the early ones, the joints tend to be these lap joints, these passing joints. So in this great barn at Cressing Temple, some of the rafters are here, and these principal timbers that sort of lock everything together are anything up to 36 feet long. So you're looking at quite an advanced system of growing timber for these early buildings. Well, the problem with buildings with aisles, the posts get in the way. And so as we get into the 14th century, people are looking at other ways of creating open space within the building without having these posts sort of coming down to the ground. And one of the earliest developments is the hammer beam truss, where basically you cut off the aisle posts in mid-air and you put in a gallows bracket to support it. And eventually these become quite decorative, as you can see here, this sort of face mask on the end of the hammer beam here on the Pilgrim's Hall at Winchester. Interestingly, it's only the posh end of the hall that's got these hammer beam trusses. The other end, they're using these crook timbers, but with very large collars here with curved braces, giving an arch-braced roof, again to give these wide open spaces. Well, the hammer beam truss was a little bit of a blue streak. It really didn't take off at all for ordinary domestic buildings, and it was only in the great buildings of the kings and the bishops, with places like Westminster Hall being sort of the zenith of the development of these types of hammer beam roofs. Well, what we find basically are two main types of construction in timber framing. We have the crook frame tradition, and this originally was thought to be the North and the Midlands mainly, using this sort of frame in the medieval period, and anything in the south of England had to be later. That was the sort of basic assumption. But the dendro dating system has shown that we've got crook buildings, crook frame buildings in the south of England just as early as in the Midlands and the North. But it's fairly short-lived down here. They're mainly dating from between 1280 and about 1480. And they're in a belt sort of going up through the centre of the country. So we've got them in Hampshire, but if you stray over into Sussex, you don't get crook frame buildings very far into Sussex. And in Kent, they're non-existent. Likewise, Essex, you don't have them, and Norfolk. So it's sort of down the centre of the country that you get these buildings. And the main difference is the system of basic technical construction. You take a tree which has got a principal branch breaking off it, and you use that sort of curved shaped timber, you split it down the middle, and you join the two together with either a collar or a tie beam to make an A-frame. And these A-frames are totally load-bearing for the whole of the roof structure. So you can take all the walls away and the roof will still stand. The rest of the infill of the timber for the wall structure is basically stopping the wind blowing through it. It's not doing a lot structurally. All the load is taken down through these great A-frames. And here you can see this is a building we discovered in the late in the 1990s in Romsey here. It was going to be demolished and a couple of new houses put on the site. It just looked like a scruffy barn with a tin roof on. And it's only when we trespassed inside we found there was a full crook frame within the building. It had spent the last 60 or 70 years as a barn and storage building. And it was restored by our Building Preservation Trust, particularly internally. And what was interesting, it had never been converted into a full sort of 2-story high domestic building. It had always been in domestic use until the last sort of 60 or 70 years. And it had a full open hall still surviving for 1.5 bays at the end of the building. and some of the infill panels at high level survived, and here we've got the handprints from the builders. And the dendro dates for this frame came back at 1376, so quite an interesting crook-framed structure. At the Chilterns Open Air Museum, they have a crook-frame barn that has been moved from Arborfield near Reading. And here you can see the full crook frame. And on this one, you've got a fairly low tie beam running across. And this overruns the A-frame at the ends here to support the wall plates for taking the roof. And then all the rest of the timber is simply secondary for the walls. It's not taking much in the way of load. And so you get this nice open space. The mid-frames, you've got basically a raised tie beam. You've just got spurs, which is sort of chopped off tie beam, if you like. It should have been across at this sort of level, like the end frame. You've got these spurs carrying the wall plate to carry the roof structure. So again, it's transmitting the load back to the main crook frame. And at the top, in order to get sort of a greater span, you've got this yoke and a little crown post here going up to, a king post going up to a ridge beam running full length of the building. Well, the way these buildings were constructed is entirely different to the other tradition in the south of England. Here, you built your crook frame on the ground, you pegged it all up as one lump, and then you winched it up vertically and then added your horizontal timbers to lock everything together. So it's built in a prefabricated form, frame by frame, raised up and then linked together to make the building. And these crook frames you could use either right down on the ground, or you could raise them and get basically raised crooks like this to simply form the roof structure. Or you could bring them a little bit lower down the wall, and this put quite a lot of thrust in the middle here. And so here we've got an example of a raised crook. This is at Bradford-on-Avon, the great barn there. And basically the crook blades finish part way down the walls. And this puts quite a lot of thrust on the walls. So you can see here we've got very large buttresses taking that thrust. But even so, these crook buildings were prone to sort of doing the splits. You've got all that load of the roof pressing down on them, and it's very easy to get sort of spread at the bottom of the crook frames. So in this particular one, you can see they put very neat tie rods through to sort of create a tie beam at this level. So quite a problem with crook buildings is particularly if the feet of the crook blades decay, you can get spread of the whole building, not just roof spread, but the whole structure. Well, the other technique of construction is the box frame construction, and this is the more typical one for most of the south of England, including Sussex and Kent and right across into the West Country. And here it's made up of a series of individual timbers. And the way it's constructed, you start with a corner post and you work out from it with your timbers, locking each timber into position as you go. So you don't create a truss and then rear it up and link them like with the crook frame buildings. It's a matter of slotting in one timber at a time. And then infill panels, these wattle and daub infill panels are put in position, or later you had sort of brick infill like this herringbone pattern here, sort of brick nogging within the frames. Well, how does one make a frame? Well, you start off with either the wall frame, or more often than not, the actual cross frames of the building, and you create them in a framing yard, basically a level area, either alongside the building or a short distance away, and the carpenter lays out the main timbers for the first truss, makes sure they're all his joints sort of work to make the truss. He then lays the next on top and so on, and plumb lines through to get his positions for all his joints. He then dismantles the trusses, lays out the main posts, and does the same for the wall plates. And so you finish up with a building in kit form in the framing yard. This is then taken out to site and constructed very rapidly on site. You don't tend to do the carpentry on the job. It's all prefabricated, make sure it all slots together, then out on site and constructed fairly swiftly. And when you look at the timbers closely, it can give you a lot of information about the way that these were constructed. Quite often you see this sort of cross marks here with sort of two lines, and this seems to be on a flatter bit of the timber. And these are levelling marks. This is where you would have put your levelling sticks for sighting through to get your joints all lining up, because timbers that they use could be sometimes quite twisted and uneven. Also around joints, you can see lines for marking out where the various notches and other bits of the joints are. So all this evidence is quite important to look for. The other thing you'll find, the medieval carpenters were quite suspicious of folklore, etc. And you'll find marks to keep witches and evil spirits at bay. And some of them done by the master carpenter. He was the man that handled things like the compass, etc., for laying out, doing the basic planning of the building. Just like the master masons with his compass and square, it was the same with the master carpenter. And so here you can see he's used his compass to create this sort of daisy wheel pattern, which was intended to sort of warn off evil spirits. And again, this one was supposed to trap any evil spirits coming in. Quite often you'll see it near door posts or this sort of thing on fireplace posts to stop the witch coming down the chimney, etc. So all things to look out for, and this is why we're not keen for people to do their paint stripping in timber frame buildings using air abrasive treatments. Quite often you can remove all this sort of information and evidence. So what about the basic way that you build one of these structures? Well, this is, as you can see, a house with a central aisled hall and then a cross wing which is jetted. And this is at the Weald Downland Museum. This was a building that was moved. And they start off with the 4 central aisle posts, putting one up at a time, linking them together with the arcade plate and the curved braces, and then linking across with the tie beams with that brace. So you finish up with something that's like a table standing in the centre of the building. And then you gradually work out piece by piece from that, putting in your corner posts, and at the same time you have to put in your curved braces and your mid rails. All this is done by hand with usually 2 or 3 poles and a ginny wheel and a bit of rope. So it's all sort of slotted in position. And you can see even the windows are prefabricated with their diamond-shaped mullions here. They have to be slotted in at the same time as the construction. So this is the box frame tradition of construction. And then you tighten the whole lot up, again, using a bit of rope and a bit of stick in the middle to create sort of a windlass, and you wind it in tight, and you can then put your pegs in. And the joints, again, have been very carefully fashioned. You cut your mortise and your tenon. You then drill your peg hole in the mortise, slot the tenon in, mark the position of the hole, pull the tenon out, and then you drill the hole slightly off-center towards the shoulder of the joint. Your peg that you put in is a dry oak peg, which is tapered. They make it using a shave, and it's tapered. You drive that in, and as you drive it in, it pulls the joint tight against the shoulder of the joint. It pulls the tenon in tight. So that's what's known as draw boring and draw tenon. And you leave the pegs out slightly because as the timber seasons, it's all green timber that was being used. If the pegs get slightly slack, you can drive them in a little bit further. So that's why pegs tend to be sort of sticking out of the joint when you see them. So here we've got the cross wing being built, ground floor built, timber by timber, the rail put on here, and then the floor joists, and this is a jetted building, so the floor joists overhang. You can then put your sill beam, your sole plate on, and then you slot your individual studs in, and then the final thing on top is the wall plate. And by this time you can dispense with your 3 legs and just use one pole, which you lash to the structure that you're building, basically, to hoist up the timbers. So very simple technique. And in fact, the carpenters on site here at Weald Downland reconstructed this building in 2 days, all by hand. No machinery used at all. So it shows how quickly you could construct one of these kits, these building kits, on a prepared base. There are various sort of styles, individual styles within the box frame tradition. On the east side of the country, just coming partly into Hampshire, you have this Wealden style house, which tends to be jetted at either one or both ends. The hall is slightly set back on the ground floor plan line alignment, and you carry the wall plate on 2 great curved braces. And so you've got a fully open central hall here with a cross passage. This is a throwback to the old medieval longhouses where you had animals at one end and living at the other. Now it's services down at the low end, and you've got the hall in the centre with the solar at the other end. So the passage goes right the way through with buttery and pantry off the cross passage. Buttery where you stored the wet items in butts, so your wine, your small beer, etc. And the pantry was the dry area where you stored the dried grain, materials, etc. over the winter, foodstuffs. Even in the east of the country, as you go through up into Norfolk and Suffolk, you get these great timber frame buildings, but here you can see the main open hall. You've got it a flush face. It's not like the Wealden style where you carry the plates through in front of the roof plate through in front of the open hall. You would have had an open central hearth in the middle with the smoke finding its way out through the roof tiles. Sometimes the more sophisticated had a smoke hood or a wattled chimney at one end of the building. Eventually, as these halls got floored over in the late 16th and 17th century, quite often the chimney was placed in the cross passage running up through the building. So you finished up with what was known as a baffle entry into the structure. Again, here we can see the evidence for that a sort of open hall structure with the smoke blackening inside. For here, this particular one had a wattle chimney within. Well, by the time we get to the 16th century, we're beginning to see the introduction of floors throughout the building. So the hall is no longer, the cold open drafty hall is no longer decided, as being acceptable, particularly in the Tudor period and onwards. And you get the central chimney stack, which is a main structural element running through the building, which takes the principal joists and supporting the secondary joists back into that sort of chimney structure. And quite often the chimneys are H-shaped in plan with a hearth on either side. The parlour, as you went in, you faced the chimney. So this is a fully developed baffle entry house. And you have the parlour on one side of the doorway and chimney, and the service end here on the other. Well, we get quite a lot of changes in the 16th century in timber framing. And this is quite a lot to do with political changes. The dissolution of the monasteries releases a lot of land and property, so land ownership changes. We've got a new sort of middle class developing, and also the break with the sort of Catholic faith, etc. We've got problems with Spain and the continent of Europe. And so there's a need to boost our shipbuilding to create a great fleet. So a lot of the forests are denuded of decent timber for building ships. You've also got what used to be sort of the managed woodland owned by the great religious institutions. They're now changing hands, and it's a quick cash crop for the new middle class. And so we find asset stripping of the great forests. We've also got at this period the introduction of glass in large quantities suitable for domestic buildings. So there's a change in the design of the buildings, no longer open windows with shutters, but you've now got glazed windows, and glass requires timber in its production. In the 1570s, we get the displacement from the continent of glass workers, particularly Huguenot glass workers. They descend on the south of England in the 1570s, and there's a good documentary entry for 1574. The city people of Salisbury complained to the king that there's not a decent stick of building timber to be had within 10 miles because of these foreign glass makers descending on the forests and burning the timber, both as fuel and to provide the potash for producing glass. And so they were banned from doing this. They move into the Midlands, where they find that the ground burns quite nicely, coal, and so they use coal for firing their glass production, but still, of course, need timber for the potash. So if you were wealthy in the 16th century and you could really afford timber, you really flouted it. And so you find many timber frame buildings of that period. You get this close studding, as you can see on the left-hand photographs here, where there's nearly as much timber as gap in between. And this is to show that you can really afford it. And so you're displaying your wealth. On the right-hand side here, you can see really exuberant framing, where most of this bracing and decorative work is not required at all. It's sheer decoration. Again, you're showing off. And also, you can afford lots of glass. So this is the period at the end of the 16th century when bay windows are coming in, and basically more glass than wall. And so here you can see, again, this is a great flouting of wealth at Morton Hall up in the north of England. And you know, the guy's been, the owner is so proud of it, it's actually inscribed on the timber here. And the carpenter was very proud of his work, and this is one of the few occasions where the carpenter's actually signed his work. Again, in urban context, one gets these quite high status buildings. The rich merchants were able to afford lots of timber. And here again, windows are in, particularly if you are producing, particularly things like weaving, etc. At the upper levels, you need lots of light, so you get these whole ranges of glazed windows. There's also quite a pressure of land in the urban areas, and so you get high-rise timber frame structures which are jetted out over to the road to give you even more space. And in some cities, within the city walls, the space is so tight that you get 2 levels of shopping. So, you know, 2 levels of shopping mall. This is in Chester, the famous shopping area there. But let's come down to ground level again, with most of the frames that we deal with tend to be sort of low status ones. Quite often timber couldn't be got from the managed woodlands for the lowest quality of buildings, but by the time you get to sort of the yeoman classes, they were getting timber from the managed woodlands rather than hedgerow material, and you were beginning to get some decent timber frames. So here you can see quite a nice late 16th century building. It's baffle entry. You've got your doorway here facing the stack. So a parlour at one end, service end at the other. But quite often in the countryside, you get problems, particularly with thatch roofs, with water dripping off, bouncing back up onto the wall bases. So quite often you lose timber frame at ground floor level. It gets built with brick, etc. And quite often we're dealing with fragmentary survivals. Quite often it's just the cross frames that survive of these lower status buildings. Where one tends to get more of frames surviving are in the great barns, because again, the release of land with the dissolution of the monasteries, the middle classes got quite a lot of good quality land. They're taking it into hand, or it's been let out on long leases. So those working on the land can afford to put up decent buildings. So here we've got one again at the Chilterns Museum, built right at the end of the 16th century. And here, the roof construction, you can see you've got these long side purlins here, and they're clasped between the principal rafter and the collar. And the collar supported on queen posts with the great tie beam coming across. And this is a very typical roof structure you'll find throughout the 15th and 16th and just into the 17th century in the south of England, these clasped purlin roofs. And in fact, this building is dated on the post as you go in through the doorway here. So our typical then queen posts and clasped purlin roof here, as you can see in this barn. As we motor through the 16th century, this system is modified, and you get butt purlins. And so the purlins are continuous, but they're jointed into the principal rafter here. And this is an inherently weak position. Right in mid-span of this principal timber, you're cutting half of it away to create mortises. And so they always failed at this point. And here you can see this has had a metal strap put on at a later date. Quite often there are timbers sort of spragged in here to stop the whole thing collapsing. And so this continuous butt purlin roof was found to be technically unstable, and so it was replaced fairly quickly. So this type of roof tends to only last in the better quality buildings for 50 or 60 years during the 16th century. And during that period, you get the development of the alternate butt purlin roof. And this is very typical from sort of about 1520 in our area, right through into the 17th century. And the beauty of this is that you are spacing your mortise holes, you're not putting them next to each other in mid-span, and quite often you have a collar or raking struts at this position to sort of help support the roof structure. So it's change by failure, by developments of technology. In the 18th century, we get the development of the king post truss. This is sort of a reintroduction. It was used in the earlier medieval period, a king post, but it's only really in the 18th century that comes back into vogue, and particularly used with softwood timbers. And so you find it hidden in the roof spaces. The timber framing at low levels now gone. You're looking at timber mainly in the roof spaces. And even with the barns, you're beginning to get this sort of downgrading of the whole structure with studs without quite often mid-rails. Sometimes you get sort of a raking timber coming across with the studs sort of nailed onto it, spiked onto it with iron nails. And in the 19th century, quite often you don't even get the principal timbers being in oak. You're now beginning to get the influx of decent softwoods, particularly from the continent. If you're in an area near a seaport, you're getting a lot of decent slow-grown softwoods coming in from the continent, particularly from the colder areas. And our agricultural buildings, as I say, follow this sort of development within our domestic buildings. In the medieval period, you get sort of fully framed buildings, and gradually as time goes on, we get simply oak being used mainly for things like the cart entries, and everything else in poorer grade timbers. During the latter part of the 18th and into the 19th century, we start to get the use of metalwork in structures, and here we get the development of the tension truss, where you're using a long bolt running through with a wedge at higher level, and you can tighten everything up here to actually tension the truss. And so these tension trusses become quite popular. To start with in the big country houses in the latter part of the 18th century, and then into the barns in the 19th century. And you can, by tensioning the trusses, you can use smaller scantling timber and also poorer quality material. Well, we still have timber frame buildings living on the end of the 18th and into the 19th century, but we're no longer showing it on the surface. And so here we've got a building of 1802 with this curved facade, and it looks like a brick structure. And it's only when you start and look closely do you find that it's in fact a timber frame structure with poor quality sort of brick infill, and then on top you've got this very fine mathematical tiling, making it look like a rather superb piece of the bricklayer's art. But in fact, you're covering up a cheap and cheerful timber frame structure underneath. And likewise, this one, it's lathed and rendered at low level with sort of ashlar lines marked out on it. And then at high level, you've got this, these mathematical tiles. And probably the end of the timber frame tradition, the traditional one, is round about the 1850s, when you've got cheap and cheerful cottages being built. This was a railway workers' cottage. Originally, it's now at the Weald Downland Open Air Museum. And again, it's fully timber framed in softwood. with cross frames of brick nogged, but the external areas, you've got lath and plaster inside, render lined out to look like stonework on the outside, on the posh sort of facade, but round the sides it's timber boarding, weatherboarding. And probably the final throw of the dice was the kit buildings, you know, the IKEA buildings of the early 20th century. These were produced in kit form. They're basically sheds, prefabricated sheds covered in tin, and these were shipped out, you know, all over the empire as little churches and chapels, etc. So that's really the last throw of the dice. Well, on to decay and repair. I'm afraid we're going to sort of overrun by a quarter of an hour due to the late start. But moving into decay and repair, the thing to remember, like any other building, the enemy of timber frame is water ingress from all the usual positions, starting at the top and working down through the roof and the wall frames, block drains, and so on. And so it's important to sort of identify the vulnerable areas. And quite often this is around the base of the timber frames, where you've got a mass of joints all coming together, where here you've got sort of two tenons coming into a heavily mortised area here, which is in the horizontal plane. So any water coming down the face of the building will find its way into this joint, and eventually it will rot out. So very important to be aware with a timber frame building where the weak points are, you know, think water. And also look for people, particularly sort of 50, 60 years ago, trying to improve the performance of the timber frame building and being concerned about rising damp and damp-proof courses. You know, damp-proof courses are a real nightmare. They were introduced in the 1870s to overcome the problem of leaking drains and sewer water seeping into the low level of buildings in places like London and the main cities. It was nothing to do with, you know, perceived problems of natural rising damp from the ground. And so retrofitting of damp-proof courses, particularly in timber frame buildings, is an absolute nightmare. Here, 30 years before this photograph was taken, somebody had inserted a damp-proof course directly underneath this sole plate. Any moisture coming down the surface of the building found the damp-proof course, and with capillary action went in underneath and rotted out the sole plate. So if you're introducing a damp-proof course in a timber frame building, it should always be a couple of courses down, and the sole plate itself should be on something like a lime mortar so that moisture can freely track out. Even worse, someone has done the plinth here with a lead flashing, which is also a damp-proof course running right through underneath this timber to the interior, and we started to get decay underneath this timber due again to capillary action, and also quite a lot of damp beneath. And last week I discovered one where they put slates right the way through to the interior. So any water coming down was directed directly into the interior of the building. One of the other sort of danger areas to look out for is the interface between the infill panel and the timber frame. And this is especially so with brickwork, where brick has been later introduced into these panels. The brick doesn't tend to move, particularly if it's been laid in a cement mortar. The timber frame moves between wetting and drying cycles, come winter, come summer, and you always get an opening joint at the interface between the two. The only time brick infill really works is if the building had been designed right at the beginning for brick infill panels, and then they sort of rebate the sides of the studs. They sort of chop a slight V into it so that the mortar goes right in, so you don't get sort of a gap right the way through. This building was a real horror that I was contacted over a few weeks ago by a prospective purchaser. Someone had been round with mastic and then masticed all the joints and for good measure round the peg holes as well. And the mastic had dried out and there was now a water trap, so any water getting in was captivated within. They'd also painted with a modern paint all the infill panels so the brickwork couldn't breathe. And so the building was getting wetter and wetter internally with water staining around all the panels and down onto the timber work as well. What does one do in this sort of situation? Well, deeply rake out these joints, and then you can cork in a modern material called Compriband, a pre-compressed mastic impregnated foam strip, and that goes deeply into the joint and then repoint with a lime mortar with hair reinforcing, and that will hopefully stick to the brick, and any slight movement of the timber and the joint opening up, you've got this gasket behind that prevents water ingress. Leaking through a roof, again, a great problem. Once you get water ingress, you can get the nails decaying, you can get collapsing purlins, all manner of problems with roofs going. Overloading of structure can again cause problems, or sometimes you've got a claim on the original builder from the 16th century. He's poorly selected his timber, and here you can see it's wild grained. Here is the timber, it's running off at an angle, absolutely the worst spot to make a joint. It's going to shear through. And again here with a tie beam with the grain running off, you can see, so it's bound to go, although it did last for 300 years, and again a knot in the mid-span. So selection of timber, very important. And it's very, very important to understand when you come to repair a timber frame building how the original method of conversion of the timber was achieved. Basically, you took the smallest log to get the largest rectangle out that you could, and you simply cut the sapwood and bark off using an axe. You sort of cut these in to get rid of the heavy material. You then used a side axe. You can see it's got a flat side. It's rather like a large chisel with a handle on, and you use that along the side of the timber to get rid of the rest of the sapwood. So you always finish up with a little bit of sapwood on the corners, and if you used it full square like this, as it seasons radially, it shrinks radially, and you get a check back towards the heart. You tended to relieve the tension in the timber by half sawing it. And as you can see, this has now retreated from that cut line, but you haven't got any nasty checks back through the timber. And for smaller material, you could quarter saw, and you could get rafters out of small scantling material, or this is ideal for corner posts, this quarter sawn material. The other thing to consider is the way that the timber has been used within the structure. In the medieval period, right through into the 18th and 19th centuries, the traditional carpenter knew how to use the timber within the building. You always put the heartwood out to the weather. So if it was a sole plate, it was heart down. For studs, it was heart out to the exterior. For corner posts, a quarter piece of timber like this with the sapwood on the inside corner. So when you look inside a timber frame building, usually the corner posts look a bit scraggy on the inside. For rafters, again, sapwood down, heartwood out towards the tiles or whatever roof covering you've got. And so again, when you look up through the roof hatch, you know, the timber looks rather grotty, you know, with bits of bark and sapwood, and the beetle have probably had a good chew at the nice tasty sapwood before they disappear to a fresh chew somewhere else. The only time you cut the timber through and through was to provide floorboarding or later weatherboarding. And this was a very expensive, in labour, it was a very expensive cut. So floorboards were highly prized in the medieval period, and into the 16th century, best wainscot panels, etc., used the best of the oak. And the oak was from managed woodlands. You grew the timber very tightly together with an understory of hazel or something like that, so the oak was fighting for light. And it was very important with oak, you wanted it to be fast grown. And so it was fighting for light, it was nice straight grained. And that was the best of the managed woodlands. And that's, of course, exactly opposite to softwood. For softwoods, you want slow-grown material with very tight growth rings to provide the best of the timber. So here we've got the use of the side axe, and this isn't adzed timber. In buildings, you rarely find timber that's been adzed unless it's curved timber. The adze was mainly used in shipbuilding for the curved ribs and timbers, etc. So it's the side axe that's been used, and you get this sort of dimpled surface on the one face of your timber. The other face is probably pit sawn. And here you can see pit or trestle sawing in action. The guy at the top was the skillful one, using the tiller to get a dead straight cut. So he was the top dog. The underdog was the poor person at the bottom that got sawdust in their eyes and hair. And you can tell a piece of pit sawn timber because the heavy strike is downwards, and then the lighter strike is pulling the blade back up again. And you get also a slight sort of curve, very, very subtle to it as the saw rocks, the blade rocks. Conversion of the timber then, very economic. You tend to leave a bit of the sapwood and bark on the edges, as you can see here. For the main posts, you fell the tree as low as possible towards the rootstock, because you have a mass of joints at the top here, and you wanted more timber, and you wanted it to be tough timber. And so where the tree roots were splaying out and withstood the wind and so on, the weather, your timber is much tougher in this area. And also the grain is flaring out. So you get this sort of natural widening of the timber at the top. So your posts are basically trees upside down with the massive joints at the rootstock end. Braces quite often were curved braces. You were taking the main boughs, you didn't waste anything, and you slice them down the middle. And in nice medieval barns, you'll find you can virtually overlay one brace on top of its pair, on top of the other, and it's the same curve, sort of back to back, where they've been sliced down. So here we've got a new timber frame building, and you can see here they've selected the timber in the correct way, so you can see that the grain is splaying outwards at the rootstock, and so they just take the bark off, and you've got this naturally flared head or jowl to the post. Here you can see somebody's cheated, and they cut it out of a larger timber, and already you can see that we've got a crack coming down here. You can see what's going to happen. Eventually, this jowl will leave the rest of the host material, and it will therefore weaken the joints. Again, here we've got curved braces, wind bracing, not cut from a sort of a straight square timber, but a curved timber to get that natural curve to the brace. So very important when repairing the building to use the timber in the correct manner to convert it correctly. And some of our better sawmills who are producing timber for the framing guys know how to convert the timber. When it comes to repairs, there's a whole host of different types of repair you can do to keep the maximum of the original material. Piecing in, slipping in a new tenon, putting a new face on a mortise that's gone, and so on. So quite a lot of different sorts of joints that can be used. Just got one or two here. This is a scarf joint on a tie beam where you're trying to keep the maximum of the original material, but to get the strength, there's basically a metal plate running through, a flitch plate, in order to sort of strengthen your repair. Here at the rafter feet, we've simply got a very cheap and cheerful repair. You've halving it onto the original and a couple of bolts through, and that does the job. With this one, they wanted an invisible repair, and the centre of the tie beam here was very badly decayed through here. And so a slot's being cut in the top with a chainsaw, not the way through. Then a T-shaped piece of metal's being dropped in the top, and it's been bolted through, but the bolt heads have been pelleted with square pellets, carefully selected so the grain is running in the same direction, and the timber is of a similar colour. And again, they let a piece into the badge shape through the centre here. And from ground level, you don't actually see this repair. It's an invisible repair, but structurally a sound one. Again, on things like barns, you can get away, the end of this softwood tie beam had rotted off, and it's a very simple repair here. They just put a bit of softwood on either side and bolted through, and there we are. It's a cost-effective repair. Here on this historic barn, the joint's gone in this corner here. Metalwork's been fashioned on site by an agricultural engineering contractor. He's welded up this to sort of fit, to slot everything together, and we've also got a tie rod to sort of help. So again here we've got sort of multiple repairs with flitch plates and straps and so on, trying to keep the maximum amount of timber in situ. And here, this is a very fancy joint with a tapered wedge in the middle to tighten this joint. So technically, it would work mechanically, but bolts, they've sort of bolted on a piece of steel as well, just to make sort of doubly sure. We then get the sort of advent of resins, and the early resin repairs left a lot to be desired. Here you can see they've plated the outside of this timber, then just poured a bucket of resin into the hole that was left. At least it's sort of a galvanized piece of steel they've used. But it's a very sort of agricultural repair. Resin repairs have now developed quite a lot, and one of the problems with the old sort of repair system was that you cut away a lot of the original timber and it finished up like a patchwork quilt. With the new resin repairs, you cut away the defective timber from the back, you leave the sort of surface of the timber with all its carpenter's marks and marks of weathering, and that's then resined onto a new structural piece of timber within the section of the timber here. So you've got the best of both worlds. Aesthetically, it looks good on the outside, and you've got the structural working of the joint within. And so this has been pioneered at the Weald Downland Air Museum as a method of repair. And again, where you've got decayed areas, here you can see they've used dry oak rather than green oak here. And they used it laminated in sections with epoxy in between to refabricate this damaged end of this principal spine beam. And again here, we've got a butt repair using dowels and resin to add on a section of decayed end to this timber. So this is sort of new pioneering work, and it'd be interesting to see how well it goes. Other traditional methods of repair Here we've got a building where it was suffering from roof spread. There was a lack of tie beams. There was only tie beams on alternate trusses. And so in between, they've slotted in a tie rod with a shoe at the end here onto the base of the principal rafter with a nut here for tightening up. And so this is quite discreet. And you can see this is a National Trust property, and they've actually used this as a method of hanging information boards on. So to the casual visitor, it simply looks like a piece of very simple display rather than actually doing a structural job. Again, here we've got a mixture in this barn of scarfed-in repairs, metal plates and tie rods. And so you can use a whole series, depending on whether it's a barn or a house which is going to be, you know, very much upmarket, and you've got to hide your repairs. What about painting of frames? You know, we think of the timber frame building, the traditional sort of chocolate box top of black and white buildings, but the blacking of timbers is really a 19th century introduction. It became popular in sort of maritime areas to start with and has spread. And, you know, the worst possible thing is sort of pitch and tar being lathered on the oak. It just ensures that any moisture that gets in through any of these cracks and shakes stays in the timber, and it accelerates rather than slows down the rot. The only buildings that were traditionally painted were where elm was used instead of oak. And elm is very susceptible to wetting and drying. And so they used an ochre and linseed paint, and you got this sort of red paint being used on elm timbers. What happened with oak? Well, they just lime washed over the infill panels and the oak frame, particularly with a new green oak frame. The lime wash on the oak tended to neutralise the acidic tanning coming out of the oak as it seasoned, and also it filled in any minor shakes that happened during the seasoning process. And so many historic frames were lime washed over the whole lot, both inside and out. What we see today tends to be weathered back frames where the weather has taken the lime wash off the exterior. But, you know, if you look closely, you can often find the residue of lime wash deep into the grain. And so again, problem frames, it's a good idea, you know, to give them a coat of lime wash, or particularly green oak to start with. It'll, you know, weather off within a year or two. Disasters with timber, particularly timber roofs, things like fires, can destroy the structural integrity of the building quite quickly. It tends to seek out the weak spots, things like joints, etc., and things like purlins burning through, again, can disrupt the whole sort of system within the structure. And so it's very important to consider when you're dealing with a building like that. Insurers tend to want you to just strip the whole lot back and put a modern cheap roof on. But in order to, you know, think about retaining the significance of the building, both aesthetically and structurally, because here we've got the whole sort of structural development of this building, it's a case of minimising the repairs, keeping as much as the timber as possible, even if it's just slightly charred. You know, clean it back so you've got rid of the loose charcoal, etc. But it can still sort of be keep the significance and the interest of that building. A couple of quick case studies. Here we've got a barn dendrodated to 1545. One of these that was built by the new middle class having gained land from Henry VIII's dissolution of the monasteries. It was hit by the storms in 87 and then 91, and was in a rather sad state, as one can see, with the aisles having collapsed and been stacked to one side, tiles taken off the roof to reduce the weight, etc. The sill walls here, the dwarf walls here, tended to sort of turn over, and so the whole thing was supported on an internal structural scaffold. One engineer suggested taking it down back to the workshop, repairing it and bringing it back out onto site. I think we would have lost 60% of the original timber doing it that way. So it was repaired in situ and very carefully repaired. Rather than replacing purlins that had gone, we put metal plates on the back, bolting through quite discreetly. You can see the traditional 19th century repair above, with sort of timber splints on either side and bolts through. More problematic was pockets of decay like this, but again, the agricultural engineer basically welding up a plate to fix on site. The split head of the post here, simple strap around both sides, and a piece of studding and bolt on either side to act as a clamp around the post to stop it splitting. Again, all very economic repairs. And there we have it in detail. Piecing in timbers, just the ends of curved braces, or the cheeks of mortise holes that had gone, or the foot of the studs that had decayed, piecing new sections in. So, although it looks a little bit of a patchwork of repairs, we were able to sort of do that building justice, and then weatherboarding on the outside. It's square cut. Shiplap boarding only came in really with machine sewing in the 19th century. The plain square-edged rather than feather-edged weatherboarding, plain square-edged, again typical right the way through into the 19th century. Important to nail it in the right position. A number of times I've seen them nailing straight through the above board, through the underside board, into the stud, and then wondering why there were cracks 6 months later running down every board. It needs to be able to dry out and season and move freely, and so the nail always goes just above the top of the board underneath. It's what's known as pressure nailing. The nail at that position prevents the curling of the board underneath, etc. So it locks everything in position. So very important, even there, to understand from the past the correct way of cladding. And there we've got the finished job. Yes, if you look closely, you can see the metal repairs, but you know it's a barn. We put back a beaten chalk floor in there, so everything can breathe nicely. And you know, that repair really did, you know, really was a success. Crook frame building here. And the problem was it had done the splits. The farmer's answer to that was corrugated iron on either side and pour concrete in to lock everything in position. We dated the building to 1391, so it was a very important, one of the only two sort of dated crook barns we've got in Hampshire. And so, you know, what was the solution? Well, again, we put a scaffold inside to sort of lift everything back into position so that all the joints worked again. But we needed to stop it doing the split. We couldn't put tie rods in because the farmer still wanted to get his equipment in here. And so we put the tie beam in below ground level here. And the tie beam was a cast concrete tie beam. And at the ends, we cast in metal blades coming up. We cut the bottom of the crook blades vertically so that the steel slotted in, drilled through, and these are inch oak pegs, so we've still got a little flexibility at this point but the building can't do the splits because it's well anchored by this below ground tie beam. So sometimes you have to think outside the box. Okay, that's the end. Sorry we've overrun. Hopefully we've still got 1 or 2 people listening in.
Kevin, you have. We've still got 18 people.
Gosh.
Which is very encouraging. And we have a couple of questions. Alison Davidson has sent in 2, which, if I may, I'll read out to you. And the issue is to plaster or not to plaster. Some of the timber buildings obviously have studs and decorative timbers to be seen as tangible evidence of wealth, but others appear to have been plastered or rendered on the outside. Should the building remain plastered if found, or is it okay to remove the plaster and expose the timber?
It's really horses for courses here. One needs to have a look to see what's happening behind. The worst possible thing is where people have put expanded mesh and cement mesh and cement render on, you know, in direct contact with the oak frame. If it's laths across with an air gap behind and then a lime render, it's still okay. It can breathe. If it's cement render, it really wants to come off. You then need to assess what the state of the structure is underneath. If the surface of the timber is badly eroded, it was obviously covered over historically to protect it. And you can either do that with, in many areas it's been done with tile hanging on timber frame buildings. You get tile hanging, sometimes it's slate hanging, sometimes it's laths with lime render. If the timber's in perfect condition, yes, it's fine, you know, taking off the render. Depends again what the infill panels are. If they're, you know, historic wattle and daub infill panels, again, you need to take a view as to what sort of condition they're in, and are you sort of jeopardizing historic materials by re-exposing them to the elements. If it's brick infill panels, well, yes, you can use the Compriband V around the edge and make sure it's line pointed. Better if those panels are not painted so you don't get rapid runoff with water finding the weakest spots, which are the joints. So really, it's a case of looking at each situation. But the key thing is, you know, cement renders on metal mesh or even battens, you know, just doesn't work.
Okay, thank you. And a question from Samir Khatri. Do you have experience of using oakum to fill the gaps between brick panels and framing?
I think, yeah, various sort of historic materials have been used in the past. And, you know, I've even seen the caulking for ships where you're sort of caulking between planks, etc., which is sort of a rope with impregnated with tar. And basically the Compriband V is a modern equivalent to that. The beauty of it is it's pre-compressed from 2 inches down to ½ an inch, and it's wanting to expand all the time. So it's actually making a tight joint, it's helping structurally, and it's allowing movement. And this is the key thing, whatever you caulk around the panels with, it needs to be able to accommodate that little bit of cyclic movement between the timber and the more rigid material.
Good. Okay, Kevin, well, thank you so much, as always, for sharing with us your extraordinary knowledge of historic buildings. We are truly blessed to have you in our patch, and we can't thank you enough. Thank you.